This video we're going to talk about how to draw the electronic diagram of an ionic compound. So to draw electronic diagram, first of all you have to draw the electronic diagram of both cation and anion together first. Remember the cation all the times will be on the left, okay, while the anion will be on the right. So you have to draw cation and anion individually first, okay? Say for example this is 2 plus, this one is 3 minus, say for example like this. Okay, and then we're going to have a cross method. Cross method means that, okay, I'm going to put the charge on the left hand side to the right, okay, and then the right charge to the left, okay? So the location that we're going to write, okay, will be here, okay? So if it is 2, I will write 2 here. If this is 3, I will write 3 in front of it. So what does that mean? Okay, so actually if you write 3, this cation means that this cation we're going to have 3 of them. Okay, if you write 2 anion, so that means this one I have 2 this kind of anion. So if you pay attention to the charge, if I have 2 3 charge 3 negative, so 2 3 negative, so in total that will be 6 negative. If you have 3 2 negative, okay, so you have 3 of the 2 positive, 2 positive 1, okay, so in total will be 6 positive. So you see that the charge on both sides, okay, should be neutralized, okay, and as an ionic compound it have to be a electrical neutral, okay. If you didn't do it correctly, you'll see something like this. For example, this is plus, this is 2 minus. If you didn't multiply this one, then you say that this is plus 1 and this one's 2 minus, okay, and then in total this will then become 1 minus, okay. So this one will not be electrical neutral. In order to do that, okay, we have to multiply this one by 2, so you have 2 plus and you have 2 minus, then they will become neutral, okay. So normally we have to draw the electron diagram, cation on the left, anion on the right, and then we do the cross method, okay. So in the syllabus, okay, we are not required you to draw electronic diagram of polyatomic ion. You don't need to, okay. So whenever you think that, oh, I have to write, say for example, you see the question say magnesium nitride, and then you think that it is NO3 minus, then it must be wrong, okay. So pay attention to that, okay. We won't ask you to draw polyatomic ion, never. So let's have a look of an example. So for sodium atom and oxygen atom, when they combine to form ionic compound, okay, we're going to draw the electronic diagram of cation, which is sodium ion on the left, and then we're going to draw anion, which is oxide ion on the right, okay. So but one thing you have to pay attention is, okay, normally in electronic diagram of ionic compound, we just need to draw the outermost shell. What means by that? Okay, have a look first. For sodium, original is 281. So for sodium ion will be 2 8 like this. Is that right? So 2 8 and then plus. So this is what you have learned. And then for oxide ion, okay, it will be 2 6 2 6, right? So when you have 2 6, you're going to receive 2 extra electrons because the electron is coming from sodium. So I use cross. Okay, I use cross to represent the electrons from sodium, and then for the rest, okay, I have to use dots to represent. Okay, remember dot and cross diagram. Don't mix up this one. Okay, so this one will become 2 negative. Okay, so basically, okay, you would think that it will be drawing like this, but if I just require you to draw outermost shell. Outermost shells, that means that I just interest in this shell and this shell. So for sodium, because the outermost shell 281, the one have been disappeared. So when you draw outermost shells only, you are allowed to draw Na plus like this, okay, because 281, this one, okay, becomes 0 already. So this one, you don't have any shells, so you don't need to draw the circle. And for the O, okay, because it is 2 6, so we have to focus this one. So for O, because this is 2 negative, so you know that 2 extra from the others. For the rest, it have to be dots. So basically, okay, this is drawing the first step. Drawing electron diagram for cation on the left, anion on the right. Next, okay, we're going to draw the cross method. Cross method, okay, so you have 2 negative here. So I will going to put 2 right in front of it. So 2 will be here. Oh, sorry. 2 will be here. Okay, it's a large one. Okay, same size of the ions. Okay. And then this one is positive, okay, the sodium ion, positive. So I'm going to put 1 here, but 1 you don't need to show. So basically like this, okay, that will be the answer. So the final answer for this one, okay, it will be like this, okay. So in exam, okay, you just need to draw things like sodium, metal ion, actually you don't need to have circles, okay, and then oxide ion, because metal ion all the time will lose electrons, okay, it will be like this. So the cross method 2, okay, right here, and that will be the answer. Okay. Oh, next, okay, one more example. Magnesium atom 2H2. When I draw the outermost shell, Mg, outermost shell 2 have been disappeared, so therefore it will become 2 plus. And then chlorine atom. Chlorine is 2H7. Okay, so therefore 2H7. The charge will be 1 negative. 1 negative. 1 negative means 1 coming from the others. For the rest is coming from itself. Okay. So what we need to do, just have the cross method. You have 2 here, so I write 2. 1 here, I write 1. But you don't need to have 1. Okay. So therefore, basically, it will be like this. Okay. That will be the answer. So now come to other example. For example, zinc atom. You say, oh, zinc atom, which group does it belong to? No worry, you know that zinc atom is zinc 2 plus, is that right? So you know zinc metal ion must be no outermost shell, become 2 plus. Bromine, this one is coming from group 7. So you know that the ionic form will be bromide, okay? So basically, okay, you have bromide. You have 1 negative. So 1 will be from from the other ions, okay, and then the other one will be circle, okay. Remember to make it a whole complete circles, okay. So it will be like that. So this one you have 2 plus. I will write 2 right there. 1 minus. Okay, I will write 1, but you don't need to. Okay. Example 4. Okay, iron 3 sulfide. Okay, so again, iron 3 is Fe3 plus because it is metal. Cation on the left. 3 plus here. You don't need to draw the circle because it disappeared outermost shells already. Okay, and then for the sulfide is 286. So therefore this one is 2 minus. So you got 2 extra. And then for the rest coming from sulfur atom. So crossover, you got 3 here, you got 2 here. That's it for the question. And very quickly, you have some more example. This one is 2,1. So you have lithium, iron. This one is 286. So you have sulfur, 2 electrons from lithium. And then for the rest will be 2 minus like this, okay. Copper 2, this is Cu2 plus O2 minus, okay. So this one you have to pay attention. When you have 2 plus and then you have 2 minus, you may think that, oh, should we cross over and write something like 2 here? Of course, no. Because you see that this one is 2 plus, this is 2 minus. When you transfer the electrons to the oxygen, 1 Cu2 plus match with 1 oxide ion, that would be okay. So therefore these 2, because they're same ratio, you don't need to have that one. Okay, so this 2 is redundant. Don't draw like this one. Okay, so just give you one more example. For example, we have nitride and you have aluminium. Okay, so for aluminium it will be Al3 plus. Nitride, it will be 3 minus. So do I need to write 3 on both sides? No, because 3 actually they will cancel each other. So this will be the answer already. Okay, so last one, silver phosphide. Silver is not from main group, but you know that Ag, the charge is Ag plus. So this one will be Ag plus. Phosphide is from group 5, 285. So therefore this one you have 1, 2, 3. Because it's 3 minus, okay. For the rest, it will be a dot, okay. So you have 3 in front of it and then 1 right there. Last one, okay. So to summarize the videos, okay, basically you draw the electron diagram of ionic compound. You need to draw electron diagram of cation on the left, Ni on the right, okay, all the time. Cat here, okay, and an N, okay, on the right, okay. And then afterward, you just cross method. So 2, you write in front of it, same size. 1, okay, you write here same size. 1 you don't need to show, okay? If it is the same ratio, like 2 to 2 become 1 to 1, or 3 to 3, it's also become 1 to 1, okay? So do remember, you don't need to draw polyatomic ion. So that means you won't draw something like Cu2 plus, okay, and then you have OH minus. We don't have things like this. Okay, because OH are 2 atoms, you can't have one circle to circle all the things in it. Okay, this one must be wrong and you don't need to draw it. Okay, so that's all for this video. Bye bye.